Hello everyone. The title of this video is Evaluate a Radical Function. Alright. Now every exercise and example I'm going to be doing in this video is taken directly from a free online textbook at openstax.org. It is their Intermediate Algebra 2nd edition text. And I'll be working under the heading Evaluate a Radical Function. Now I'm only going to be doing the even numbered exercises under this heading, because you notice that the odd numbered exercises, you can click on the link on the question number and it will take you to another part of the text with the solutions, but the even numbered exercises do not have this. So I'll be working on the even numbered exercises, the ones you can't see the solutions to. I will also have timestamps for each exercise, each example in the description of the video. Okay, so I'll have example 1 in the description. That will correspond to exercise 352. Example 2 will correspond to 354. Example 3 to 356, and so on for all the even numbered problems up to 366. So you can click on, the different timestamps if you wish to see a particular question. Alright, and then one other request I would have of you is that when I start a new question, pause the video and try to work on it yourself first. See if you can figure it out on your own, and then watch me do it, right, and compare. Right, because if you're watching me do these problems without practicing yourself, chances are you're not learning all that much. Alright, so the first question I'll be working on is number 352, which I've written out. So you see I have example 1, and underneath it I have the exercise from the text that corresponds to, right, number 352. And all we're asked to do for every exercise of this video is evaluate the function. Right. So remember what a function is. A function is a set of ordered pairs. Right? It's a relation, but it's a relation in which every value of the domain, right, every input corresponds to exactly one value of the range, right? So every input goes with exactly one output. So in number 1, right, we're given this function called f, right, and the input variable is called x, right, and this is f of x, which is the output, right? F of x gives me the output. And over here on this side of the equal sign is how the output is calculated given an input of x. It's the square root of 6x minus 5. And again, all we're asked to do is evaluate. Plug in an input, get an output, right? What's the value of the function? What's the output at a particular input? Alright, so for part A, we're asked to evaluate the function f at x equals 5. Alright, this is replacing x, right? You replace x with 5. The input is 5. So I do that in the rule here. So f of 5 would be the square root of 6 times 5, right, replacing x, minus 5. Alright, now evaluate, simplify the radicand first, right? It's all underneath this square root symbol. 6 times 5 is 30. 30 minus 5 is 25, right? So this is the square root. And don't forget this symbol means the non-negative square root of 25, which is 5, right? 5 squared is 25. And there we go. That's it. That is all we're asked to do, is find the value of this function f when the input is 5. So we're seeing when the input is 5, the output of this function is also 5. Now you may recall from earlier videos, other videos I've made, saying that f of 5 equals 5 is the same thing as saying that the ordered pair 5, comma 5, right, input 5, output 5, is a point, an ordered pair, on the graph of this function f, on the graph of f, which I'll point out to you in a little bit. Right? I'll show you a graph of this function on a free online graphing calculator. Okay. Part B, same function f here that we were given. We're asked to find the value of the function when the input is -1. So this is the square root of 6 times, and then x becomes -1 minus 5. All right, 6 times -1 is -6. Minus 5 is -11, and that's a problem. All right, this is the square root of -11. It's like, uh-oh. Remember, even roots of negative numbers are not real numbers. Right? They're imaginary numbers, and we'll get into imaginary numbers in a later video, in a later section of this OpenStax Intermediate Algebra textbook. But for right now, all we're going to say is this is not a real number. Right? The square root of -11. Right? There's no real number that you can square and get -11 back. And what that tells me about the graph is this as well. When I input -1, if I was graphing on the xy plane, remember the x-axis and the y-axis represent real numbers, real number inputs, real number outputs. So this tells me that when I input -1, I don't get a real number output. So that means there is no point on the graph of f with an x-coordinate of -1, with the input -1. Alright, let me show you this stuff, right, on the graph of this function. Alright, so I'm going to pull up a website. Alright, it's a free online graphing calculator at a site called Desmos.com. I believe I've pointed this out in other videos if you've been following. Desmos.com. And yeah, it's a free, right, very, very useful calculator. So in this first spot here, I'm going to put in the function we were given. F of x equals the square root, which you can just type SQRT, and the square root symbol comes up, and then the square root of 6x minus 5. And you see this red graph showing up here with all these ordered pairs that belong to this function. Right? And if you highlight one of them, you see that 5/6, which is 0.833333. 5, 6, comma 0, right? If I input 5, 6, you'd get the square root of 0. And let me put in that, remember we said the ordered pair 5, comma 5 was on this, right? Input 5, output 5. There's that blue point showing up, and you see the blue point is definitely on this red graph, right? It is an ordered pair belonging to this function called f. And then you see how the graph, starts at this 5, 6, comma 0, and then goes up this way. Notice that there are no ordered pairs, no points of the graph to the left of this. So when I punch in, you see f of -1, like they asked for in part B. See how it's undefined? Now they're saying undefined, but it's really, it's an imaginary number. It's not real. But you notice that there's no point on the graph with an x-coordinate of -1, right? There's no point on the graph with any x-coordinate less than 5/6. And we'll talk about that in a future video. All right, talking about the domain of a radical function. All right, but for right now, we're just evaluating stuff. All right. Now, the other function, oh, not the other function. I mean the next question. All right. So that was number 1. Number 352. Now, question 2 is exercise 354 in the text. Same thing, only the function's called g this time. So g of x equals, the square root of 3x plus 1. And after I'm done with parts A and B here, I'll once again go to that Desmos graphing calculator and show you the picture of this, the graph of this function, all the ordered pairs that belong to function g with real number inputs and real number outputs. Alright, so part A, they're asking us, what's the value of g? What's the output when the input is 8? So it's simply the square root of 3 times, x is 8, input is 8, plus 1. 3 times 8 is 24, plus 1 is 25, right? So this is the square root of 25 again, which is just 5, right? Positive 5. Once again, I know -5 squared is also 25, but don't forget this symbol, square root symbol, even root symbol, is asking you for the non-negative root. Okay, so once again, the result is 5. So input 8, output 5. And once again, what that means is that the ordered pair, 8, 5, would be on the graph of g, right? I'll just say it is on graph. It would be on the graph of this function called g. All right, then part B, what's g of 5, right? What's the output when the input is 5? So easy enough, right? The square root of 3 times 5, right, replaces x plus 1. Now 3 times 5 is 15, plus 1 is 16. And this has a non-negative square root of 4. Right? So the result here is 4. Right? The output, the value of the function at x equals 5. And just to keep up with the same statements here, this means that input 5, output 4, the ordered pair 5, 4 would be on the graph of this function. And once again, I'll show you on the Desmos site. Right, so back to the desmos.com. Here's now let me enter the function we were given, g of x equals the square root of 3x plus 1. And here you go, a very similar shape to the last one, only it's starting here at -1/3, 0. Alright, if I were to input -1/3 for x, you'd get 0 for y. If I were to input 0 for x, you'd get 1 as your output, right, the square root of 1. And let me put in those other ordered pairs that we said would be there, right? I'd have, remember, one of them was input 8, output 5. Right, and there it is, that little black dot that showed up. See, it's definitely on this graph, 8, 5. And from part B, we saw that when we had an input of 5, we had an output of 4, 5, 4, and there's that, you see that red point that just showed up, right? 5, comma 4. Definitely on this purple graph. Right. Wonderful. Okay. So let me clear these out, and we'll move on to the next question. Right, that's all the same. Right, but not always square roots though. Right, these first few examples, first several questions are square roots, but we'll eventually get into different roots, cube roots, and stuff. All right, so number 3, corresponding to number 356 in the text, we have a function called capital F, and the input is x, right? And the output is f of x is the square root of 8 minus 4x. Here's how you calculate the output. Part A, what's f of 1? Right, so what's the value of this function called f when the input is 1? So it's easy enough, right? The square root of 8 minus 4 times 1. And that's the square root of 4, which is 2. Okay. That's the answer. That's what they're looking for. The value of f at 1 is 2. And this means that the ordered pair 1, 2 would be on graph. I'll just say on graph. Right, and I'll show you with the Desmos site again. All right, then what about f of negative 2, right? Inputting negative 2 for x. What's the output? F of negative 2. Again, easy enough. Just plug in negative 2 for x. This is the square root of 8 minus 4 times negative 2. Well, that would be 8 plus 8. So the square root of 16, which is 4. Right? And that's what they want, right? The value of the function at an input of negative 2. And this tells us that negative 2 comma 4. Right? Input negative 2, output 4. This is a point on the graph of this function called capital F. Let me show that to you again. All right. So I'm just going to enter the function here as is, capital F of x equals the square root of 8 minus 4x. And look at this. Now it's like it starts here at 2, 0, but then kind of goes to the left, Input 2, output 0, input 0, output square root of 8, right, which is about 2.828. Square root of 8 would be the output. But let me just, put in these other points, these points that we got from part A and part B of this question, right? We said when the input was 1, the output was 2, right? 1, 2. And there it is, that green point that just showed up on and you see it's on the graph for certain. Belongs to this function capital F. And then we saw input negative 2, comma, output 4, and you see that purple point showing up, also on the graph. Excellent. Right. Negative 2, 4, 1, 2. Wonderful. Right. Now if they didn't show up on the graph, then we probably did something wrong. Right. All right. Next question. All right, so question 4 is exercise 358. We're given this function called capital G of x. Again, the input is x. And the output, g of x, is calculated this way, the square root of 4x plus 1. All right, so g of 11. All right, g of 11 be the square root of 4 times 11 plus 1, which is, the square root of, that's 44 plus 1, the square root of 45, which, unlike the earlier questions, this is not a perfect square, right? 45 is not a perfect square. but you will be asked to simplify your radicals, right? Make sure there's no perfect square factor of the radicand. 45 is 9 times 5, right? So I can break this up using the product property as the square root of 9 times the square root of 5, and the square root of 9 is 3. All right, so it's 3 times the square root of 5. And that's it. Now, we weren't asked to round anything. Now, if you want to round, I could just go back to the calculator here. You don't have to enter functions. It still works as a calculator. 3 times the square root of 5 is about 6.708,203,9325. All right. Yeah, so this is approximately 6.708 if you were asked to round to 3 decimal places, or whatever. All right, and then once again, this g of 11 equals 3 times the square root of 5 tells us an ordered pair, tells us a point on the graph of this function g. Input 11, comma, output 3 times the square root of 5. But you're going to see on the Desmos site, they'll have 6.708. They usually round to 3 decimal places if it's not a nice number. So that point would be on the graph of g. All right, and same thing for part B. What's the value of this function when the input is 2? All right, so the square root of 4 times 2 plus 1. Now this is a nice square, right? 4 times 2 is 8, plus 1 is 9. The square root of 9 is just 3, right? So the answer here is 3. Right? And once again, this tells us that input 2, comma, output 3. This ordered pair 2, comma 3 is on the graph of this function. All right, let me show you. All right, go back to the Desmos site. Let me get rid of this number. Enter our function, capital G of x equals the square root of 4x plus 1. There it is, that red graph, all these ordered pairs, negative 1/4, comma, input negative 1/4, output 0. Here's input 0, output 1. And let me just show you that, the point. Now let me zoom this, move this a little bit. You can kind of move it like any map on your phone. Just kind of click on it and drag it, or zoom in and out by scrolling. We said input 11, output 3 times the square root of 5. Right? And you see that blue point showing up there? That is on the red graph for sure. And you see it says 6.708, right? Rounded to 3 decimal places. The other point we got from part B was, input 2, output 3. Right? And there it is, that green point that just showed up right there. Wonderful. And again, if the points weren't on the graph, then I would realize that I've done something incorrect. Fantastic. All right, so back to the questions. Next question. All right, so now we're going to get into some cube roots. So question 5 corresponds to 360 from the text. We have, little g of x is the name of the little g, and the input's x. Output g of x is the cube root of 7x minus 1. So you're think of perfect cubes. Part A, what's the value of function g when the input is 4? So this is the cube root of 7 times 4 minus 1. That's 28 minus 1. So the cube root of 27, which is 3, right? 3 to the third power is 27. So the value of this function when the input is 4 is 3. All right, and then if you want to say something about the graph of function g here, the ordered pair input 4, comma, output 3. Right, this would be on the graph of the function. Okay. And how about g of -1? What's the output when the input is -1? So this would be the cube root of 7 times -1 minus 1. This would be -7 minus 1 is -8. So it's the cube root of -8, which is -2. That's a nice perfect cube, right? -2 to the third power is -8. And there you go. That's the response they wanted. The value of the function. But again, we can say something about the graph, right? Input -1, output -2. So -1, comma, -2. This ordered pair would be on the graph of this function called g. And let me do that. All right, let me show you again. All right, so back to the Desmos website now. We have a little g of x equals, now the cube root symbol I gotta enter. Now there's a keyboard thing down here, a keypad, which you can look at, new functions and whatnot, all sorts of symbols and stuff. Now I see the square root symbol. Let me go to hit this functions button, and let's see, stats, distance, miscellaneous. Here we go. See, there's an nth root in this miscellaneous functions area. Put that in, and then you see it has now the cursor is where I would enter the index of 3 for the cube root. All right, and then I'll put the keyboard back down. All right, so the cube root of 7x minus 1. And look at this crazy function here, right? A little S curve. What the heck is going on? Don't need that. But you see the curve here? Right. Now, if you want to see more of the graph, you can always move this expression list off to the side like this. Right. But yeah, and then hit home to center it at the origin. Alright, so you see this graph here. Now, but I want to enter those points that we found, right? Just to show you, right? One of the ordered pairs we said was in this function was 4, 3. Right? You see that black point showing up on the function. Input 4, output 3. Alright, but also you got, input 1/7, output 0. Here, input 0, output -1, right? There's infinitely many ordered pairs on all these. You've seen them. And the other one we got from part B was, input -1, comma, output -2. And you see that red point showing up here, -1, comma, and it is on the graph. All right, once again, if it weren't on the graph, then you realize, oh, I have a problem. Either I typed something in wrong or I wrote something wrong. Right? But this is a good way to check your work. Wonderful. Next question. All right, so number 6, same thing. We have this is number 362 in the text. We have this function called h. The input is x, and the output is h of x, right? H of x equals, and then here's how you calculate the output, the cube root of x squared plus 4. All right, so part A, I'm inputting -2 for x. What's h of -2? Right, so this is the cube root of, -2 squared, right? Don't forget parentheses. Usually I put parentheses around what I'm replacing, what I'm inputting, and then plus 4. Right? Because very often people mess up and put, they'll just square the 2 and not the negative sign, right? Not -2, but -2 should be squared, right? Whatever x is, whatever the input is, should be squared. So that's positive 4 plus 4. This is 8, right? This is the cube root of 8, which is 2. Right? So the answer they're looking for here is 2. Right, and then once again, like I've done with all the other questions, this tells us something about the graph of this function h, that the ordered pair -2, 2 would be on the graph, right? Input -2, output 2 is on the graph of this function h. Okay. Part B, we have h of 6, right? So I'm just inputting 6 for x, so that's the cube root of 6 squared plus 4. Right, that's 36 plus 4 is 40. Right, the cube root of 40, which now 40 is not a perfect cube, but you will be asked to, simplify your radicals. The cube root of 40, think of perfect cubes that go into 40 evenly. Well, 8 goes into 40 evenly. 8's a perfect cube. It's 2 cubed, right? So this is the cube root of 8 times the cube root of 5 using the product property for radicals. And so we end up with 2 times the cube root of 5, right, when it's totally simplified. Okay, and I'll circle that, right? That's what they're asking for. What's the value of the function? Now we could approximate this to 3 decimal places. Just going back to that free, again, Desmos calculator, you can just enter numbers and it'll give you values, right? So 2 times, now, instead of the cube root of, looking for the cube root thing again, I'm going to go 5 and then, the caret button above the number 6, shift 6. And then remember the 1/3 power. Remember the 1/3 power was the cube root. So that's 2 times, 5 to the 1/3 power. 2 times the cube root of 5, 3.4199, so 3.420. If I round to 3 decimal places like they do in the Desmos here, this is approximately 3.420. Right. But yeah, so this is, again, telling me something about the graph of this function. Right? Input 6, output 2 times the cube root of 5. Right? That point is on the graph. And when I see it in Desmos, it's going to be 6, 3.420, right, as you'll see. Let me go back to the site here, and we'll enter our function. Right, it was h of x equals, and instead of finding the cube root thing again, I'm going to put the radicand in. It was x squared plus 4, right, to the 1/3 power. Right, there's your cube root of x squared plus 4. Kind of a weird looking function here. And just enter those ordered pairs we said were on this, right? From part A, we said, -2, 2 should be on this, and look at it is, right? It is. See, there's -2, 2. Here's 0, whatever the cube root of 4 is, 1.587. And then we got from part B, 6, 2 times the cube root of 5, so 2 times 5 to the 1/3 power. And there it is, right? Oops. There it is, this point here, right? 3.420, 3.42, right? Approximately 2 times the cube root of 5, and you see it is indeed a point on the graph of the function. Wonderful. So we did well. Great. All right, next question. All right, and this is the last page. All right, just got 2 more here, number 7 and number 8. All right, so now we have 4th roots. All right, so you got to remember 4th roots, even roots. If we're talking about graphs, right, again, the x-axis and y-axis are representing real numbers. So if the radicand is ever negative, you won't get an output, right? You won't get a real number output for a 4th root. All right, well, let's see. Let's see what happens here. So 7 is exercise 364. We have this function called little f, right? The input is x. F of x equals the 4th root of 3x cubed. All right, so part A is what's f of 0, right? So the input 0, what's the output? Right, so the 4th root of 3 times, 0 cubed. Well, that's just 0. right? And any root of 0 is simply 0. Right? 0 to the fourth power would be 0. Alright, so this is telling me that the origin is going to be on this graph, the graph of f of this function. Right? Input 0, output 0. Right? So the ordered pair 0, 0. The origin is going to be on the graph of f. Right? Part B, what's f of 3? Right? So I input 3 for x. That's the fourth root of 3 times 3 to the third. Well, this would just be 3 to the fourth. And the fourth root of 3 to the fourth, which is the fourth root of 81, would just be 3. Right? 3 to the fourth power is 81. Right? And so we're told, this tells us that input 3, output 3, right? Input 3, comma, output 3, the ordered pair 3, comma 3, would be on the graph of this function. Now, please understand, this is only 2 ordered pairs we found. The input's not always going to be the same as the output. Right? If I put in 1, we'd have input 1, comma, output would be the fourth root of 3. Right? The output would not be 1. Right, let me enter this function. Right? So back here we got it was called little f of x equals. Now once again, I'm just going to put in parentheses, I'm going to put the radicand, which was 3x cubed, and then raise it to the 1/4 power. Right, that was the fourth root. Right, you could also find that nth root in the miscellaneous functions in the keypad again, but I like to not have to bring the keypad up as much as possible. So yeah, you see 0, 0 there. Right, we said that earlier. The origin is on this graph clearly. And then one other point was 3, comma 3, right? And hopefully that shows up on the graph as well. And look at that, right? That blue point definitely showing up on the graph, on the red graph there. Right? Wonderful. Okay, and then one final question. All right, number 8, exercise 366 in the text. We have function g of x, right? The input's x, the output's g of x, and here's how you calculate the output. It's the fourth root of 8 minus 4x. Alright, so part A, what's g of negative 6? Right? Input negative 6 for x. So it's the fourth root of 8 minus 4 times negative 6. Well, that's 8 plus 24. So that'd be the fourth root of 32. All right. Now 32 is 2 to the 5th power. It's not a perfect fourth power, but I can split this up to to simplify the radical. It's the fourth root of 16, which is 2 to the 4th, right? A fourth power, times the fourth root of 2, right? Using the product property for radicals. And so what I end up with here as my output is 2 times the fourth root of 2. And that's it. That's what we're being asked for. What's the value of this function when the input is negative 6? The output is 2 times the fourth root of 2, or the fourth root of 32, same thing. And I'll enter that into my calculator. We have I'll just put 32 to the 1/4 power. Right, 1/4. That's that's the same thing as what I have. 2 times the fourth root of 2, or the fourth root of 32. About 2.378 if I round to 3 decimal places, like they will on the graph when I graph it. So this is approximately 2.378. Right. This is the number we'll see when I put it on the graph later. And then the point on the graph of this function g would be input negative 6, so negative 6 for the x-coordinate, and then output 2 times the fourth root of 2, or just the fourth root of 32 if you want to make it smaller, right? But this point would be on the graph of this function g. Alright, then part B, same thing. What's g of 2? Right, input 2, so the fourth root of 8 minus 4 times 2. Well, that's 8 minus 8. That's 0. All right, this is the fourth root of 0, which is just 0. All right, so that's what they want. All right, what's the value of the function when the input is positive 2? And so we can say something about the graph now. Right, the graph of this function will have the ordered pair 2, 0. Right, input 2, output 0. This will be on the graph. And let's see. All right, so I'm going to enter this one final function here. So g of x was equal to the fourth root of 8 minus 4x. So I'm going to put 8 minus 4x raised to the 1/4 power for the fourth root. There you go, this purple graph showing up. And let's just see that the ordered pairs we said would be on this graph are actually on it. The first one was, -6 for the input, comma, and then 2 times the fourth root of 2, right? So 2 times 2 raised to the 1/4 power. Make sure just that, 2 is raised to the 1/4. And look at that, that black point that just showed up is indeed on the graph. And when I click on it, you're going to see that the y coordinate they'll say is 2.378, right? Which is what we said it rounded to 3 decimal places. Great. And then the other point we found on this graph was the ordered pair 2, 0, right? 2, 0, and there it is, right? You see it right there on the very, basically like the beginning of the graph before you start moving left. And you could find all sorts of other points, right? Just put in values less than 2, and you'll get a point on this graph. Notice that values greater than 2 would be bad, right? If I put in a value greater than 2, you'll be taking the fourth root of a negative number, which isn't real, right? So that's why there aren't any points to the right of x equals 2. Hope that's clear. Wonderful. All right, and that's it. That's all the questions I have for you here. So I'm hoping that watching me go through these 8 questions help you in some way when you're asked to evaluate a radical function on your own. And thank you very much for watching.